Okay, now let's proceed to the scientific measurement and analysis. During an expression, measurement is the comparison of some aspect of an object or event with a standard unit. Scientists around the world can compare and analyze each other's measurement because scientists use a common system of measurement called the International System of Units or SI. This system includes standard measurements for length, mass, temperature, and volume. All SI units are based on intervals of 10. The reference table section of the appendix contains a chart of SI unit. The next slide is accuracy and precision. Accuracy and precision are important in scientific measurements. Accuracy refers to how close a measurement is to the true value of the thing being measured. So, it is very important to when we experiment that we must be accurate or precise. So, precision is the exactness of the measurement. For example, a distance that is measured in millimeters is more precise than a distance that is measured in centimeters. Measurements can be precise and yet inaccurate. The next one is error. Error is an expression of the amount of imprecision or variation in a set of measurements. Error is commonly expressed as percentage error or as a confidence interval. So, kung hindi precise yung measurements, that is what we call error. The percentage error naman is the percentage of deviation of an experimental value from an accepted value. Percentage error is how big your errors are when you measure something in an experiment. For example, a 1% error means that you got very close to the accepted value, while 45% means that you were quite a long way off from the true value. And lastly, the confidence interval. A confidence interval describes the range of values for a set percentage of measurement.
Right. I would like to butt in on accuracy and precision, ano. Kasi class, quantitative data, alam natin na quantitative data, when we, especially in experiments, ano, in testing hypothesis, there are instances that we really look into the data, the precision of the data. Kaya sa hard sciences actually, in your biological statistics, tinitingnan natin yung tinatawag natin na percentage of error. Especially pag nagti-test tayo, nag-hypothesis testing na tayo, tinitingnan natin yung confidence interval or yung degree of error. Tinitingnan natin, would it be, gagamit ako ng 5% level of significance, wherein that means 95% is the expected precision of your data. Ano? So ginagawa natin ito usually if we wanted to validate or to test uh, data that is quantitative in nature.
The next slide is observations and models. In earth science, using controlled experiment to test a hypothesis is often impossible. When experiments are impossible, scientists make additional observations to gather evidence. The hypothesis is then tested by examining how well the hypothesis fits or explains all of the known evidence. So, in some cases, there is no good way to test a hypothesis using a controlled experiment for practical or ethical reasons. In that case, a scientist may test a hypothesis by making predictions about patterns that should be seen in nature if the hypothesis is correct. Scientists also use models to simulate is a description, representation, or imitation of an object system, process, or concept. Scientists use several types of models. These are the computer model and physical model. Kumbaga, kumbaga, ito yung kanilang visual way of linking theory with experiment, and they guide research by being simplified representation of an engine that enable prediction. You can see the picture that are the example of models showing two mountains. Right, that is used to track erosion along the Tibetan Plateau. And on the left side, that is a physical model. So these are the types of models: theoretical models, conceptual models, mathematical models, and computer models. Okay, physical models are three-dimensional models that can be touched. Maps and charts are examples of graphical models. Conceptual models are verbal or graphical models that represent how a system works or is organized rather. Mathematical models are mathematical equations that represent the way a system or process works. Example: true equations and graphs are the most common types of mathematical model. Computer models are a kind of mathematical model that use the high speed and efficiency of a computer to make calculations and display results. After a good computer model has been created, scientists can perform experiments by manipulating variables much as they would when performing a physical experiment.
Before we go to acceptance of scientific ideas, let's have first the scientific models. Well, classmate mentioned physical models, conceptual models, mathematical models, and computer models. If you could notice, class, these models are, ano siya, these are actually, we really need to apprehend the features in crafting or integrating scientific models in our lesson kasi gagamitin natin itong mga to. Now, presented, just like in physical models, siguro one thing that we have to remember or to be acquainted siguro that we have to establish pag nagpapagawa tayo ng physical model sa mga estudyante natin na 'di ba mapapansin natin scalable na siya in a scale. That's the reason why presented previously prior to scientific models that the SI units presented to us the universal system of units in order for us to at least present realistic model that is actually para siyang replica or an actual image of an intended concept siguro or an of scientific standpoint or scientific concept that we wanted to put into a certain model. For example, as presented hindi naman po pwede or hindi natin kayang dalhin ng teacher ang Mount Everest sa classroom. Hindi natin po pwede dalhin ang buong elepante sa classroom or ang buong elephant just to present and to give the details to our students. We cannot really present to the students the actual image or I mean the actual atoms. We can't do that, but by having these scientific models we can allow our students to look into the details, the features. For example, in anatomy, paano natin maipapakita ang flow, paano nangyayari ang peristaltic activities or yung churning, paano nangyayari ang mechanical and yung chemical digestion. So we can actually model that or we can do that by having presenting to them the so-called scientific models na ipapakita natin yon. These are the importance of having this scientific models. Alright? Sige, continue tayo on acceptance of scientific ideas.
Okay, thanks for that, sir. The next slide is acceptance of scientific ideas. When scientists reach a conclusion, they introduce their findings to the scientific community. New scientific ideas undergo review and testing by other scientists before the ideas are accepted. Publications of results and conclusion. Scientists commonly present the results of their work in scientific journals or at professional meetings.
Acceptance of scientific ideas class. This is Good point, ano? Lalo na when you are already in service, we have to allow our students that after they perform certain experiments sa investigatory project or mini research siguro or kahit ano lang, quick lab, kahit a minute quick laboratory activities, we have to allow our students to present their accomplished or performed experiments. Kailangan i-allow natin yon. Though hindi naman hanggang umabot dito sa minimension natin na publication of results, even kahit sa communication lang, because as presented doon sa ating scientific process, that after performing your experiments and proving your hypothesis, you have to communicate your results. And communication can be done actually even in the four corners of the classroom. Allow your students, siguro you have to let your students to present their output in front of their classmates para maipakita naman of what really happened during the course of their experiments. Ano yung mga ginawa nila? What are those setups being prepared? All right? So that is the reason why I am encouraging you na once you are in service, allow your students. Do not let your students to right after conducting the experiments or their mini lab, tapos na, wala nang nangyari. So, kaya, ang nangyayari sa mga estudyante natin, naboboard sila. Hindi na nila nagugustuhan ng science. Pero pag na-allow natin yan, we have to scaffold them. Di ba meron tayong mga estudyante na mahiyain? We have to scaffold them. We have to create a bridge, a channel, na allowing them to actually provide explanation, mai-present nila sa classmates nila kung ano talaga ang nangyari sa pag-perform nila ng experiment. Kasi uh, uh, that will syempre promote and elevate their capacity, especially sa communication process. Take note that is of the skill, one of the skills na kailangan ma-promote natin or ma-enrich sa ating mga estudyante. Okay, nakuha class?
Yes, sir.
Yes, sir. As you can see, that picture are the meteorologists at a conference in California are watching the science on a sphere exhibit. They are wearing 3D glasses to better see the complex and changing three-dimensional display of global temperatures.
Bago tayo mag-proceed, meron si John ring sinabi dito, ano? So talagang totoong nangyayari ito. Sabi niya sa classroom natin during high school, ginapaslo pa ang mga apparatus and base daw masira. We have to change this mind framing, ano? This type of attitude or siguro once we are now in service, ano, kinakailangan masira ang gamit kasi mas ibahan siya na masira na dili ginagamit, tama? Mas maganda na nasira siya kasi ginamit sa aton mga estudyante. Kasi actually, the Department of Education actually nagpo-provide siya ng mga basic laboratory apparatuses na kailangan na siya namang applicable lalo na sa mga far-flung areas na talagang magagamit natin. We have to maximize this laboratory apparatuses, ano, pag dumating na kayo sa talagang nasa field na kayo, gamitin natin ito because eto lang, it is through hands-on activities that the students can actually validate, put into practice those theories, those concepts that we are discussing in our classroom. Kasi once na they are performing on their own, self-paced learning na sila, nagkakandak sila sa sarili nila, ginagawa nilang activity nila sa kanilang pamamaraan, doon mas lalong natututo ang ating mga estudyante. Nakuha, class? At isa pa,
Yes, sir.
lalo na pag departmentalized ang school, we can actually ask the permission from our department head, from our school principal, kasi yun ang ikakagana ng ating mga estudyante. Kailangan palawigin natin, gamitin natin yan. Kahit nag-iisang microscope lang yan. Kung sira man, we can mimic, kasi pwede naman natin i-mimic yan ang perform ng laboratory apparatuses, I mean ang laboratory experiments, kung papaano ginagamit ang ang microscope, kahit microscope man lang. Marunong kaya gumamit ng microscope ang mga bata? Alam kaya ng mga estudyante natin paano gamitin ang ammeter, ang voltmeter, paano natin measure ang voltage, ang ampere, alright? Sige, proceed tayo.
Scientists in any one research group tend to view scientific ideas similarly. Therefore, they may be biased in their experimental design or data analysis. To reduce bias, scientists submit their ideas to other scientists for peer review. Peer review is the process in which several experts on a given topic review another expert to work on that topic before the work gets.
Okay, so before tayo mag-continue class, ang peer review naman, those during your high school and even during my high school time and even college siguro, I did not experience such a thing that actually we were not exposed that much pagdating sa conduct of experiments or conducting or formulating a research article. Now, in our scenario class, I am encouraging you na when you are in field na, lalo na sa high school kasi it is in the secondary time that we have to build a strong foundation when it comes to scientific concept. Paano natin magagawa ito? Paano natin mako-contextualize ang peer review process or peer review activity? We can actually set class. Pwede tayo mag-conduct ng activity like district-wide or kahit school-based lang sa papanong paraan. We can set yung school-based conference or school-based convention, science activities or science affair that our students are allowed to present their crafted or accomplished science investigatory project. And we can invite experts on that field, science field, outside. Pwede tayo mag-invite siguro kung kilala nyo, friend nyo na science teacher or master teacher, science master teacher coming from other schools in order to at least critic or evaluate your output. Then po pwede tayo din, di ba, meron tayong mga school paper. Sa school paper siguro, baka pwedeng may part doon na we can integrate or we can publish portion of the studies of or articles of our students. Base doon kung ano yung perform nila na activity. Yung mga simple investigatory project that will allow our students na para makuha ng mga estudyante na, ay, ang sarap pala sa pakiramdam na yung aming science investigatory project is nailalathala, na-publish siya sa aming school paper. Kahit yung just the result alone, nakita ng bata na hala, kaganda. Kasi may encourage lalo. Talagang magkakaroon ng eagerness to learn more in science ng estudyante natin. These are just some of the practices na presenting to you na perhaps pagdating nyo sa field, pagdating nyo sa talagang teaching, nasa profession na talaga kayo, into profession na, nasa field na kayo, talagang kasi wala tayong iniisip kundi ang ma-promote natin ang science education, lalo na sa mga estudyante natin. Alright? So, pwede tayong mag-invite ng mga magagaling na science galing sa ibang school. Pwede nating i-invite nyo. Siguro, a couple of snacks, paistakon lang natin sinda. Pwede na yon kasi nag-a-add naman sa kanila yun ng points. Mabigyan sila ng certificate. So, pwede yon. Pwede ito natin gawin. We can contextualize this situation. But there are instances, class, like may mga professional organization na nagsiset ng ini-encourage, nag-i-invite ng mga estudyante. Pag alam natin na meron tayong investigatory experiments or project na ginawa ng mga estudyante natin na we can actually present sa region. Kasi merong mga ganito, allow our students, i-encourage natin ng estudyante nato na mag-join. Kasi isa yan, isang learning area pa rin yang, isang lugar kung saan hindi lang matututo ang ating mga estudyante sa loob ng klase, kundi matututo pa rin sila sa labas. Okay? So are you getting my point, class?
Yes po, sir.
Okay, sige, let's continue. Is the next presenter, next part?